Hello there, welcome to the AS Maths Pure June 2023 paper. Here on a vectors question, question 13. Relative to a fixed point O, point A has the position vector 10i minus 3j, point B has this position vector, and C has this position vector. Find the vector from A to B. So to easily find the vector from A to B is, you can do position B, take away position A. So that's going to be minus 8, 9. I'm rewriting them as column vectors. Subtract 10 minus 3. So doing this, minus 8 minus 10 gives me minus 18. And 3 9 minus 3 gives me 12. So this is going to be minus 18i. Rewrite the question in terms of the format of the... Rewrite the answer in terms of the format of the question. Minus 18i plus 12j. Moving on to part B, find the modulus of this vector. Okay, so that's going to be a Pythagoras calculation of 18 squared add 12 squared. 18 squared add 12 squared, just going to get my calculator. 18 squared plus 12 squared is 6 root 13. And we'll leave the answer like that as a simplified surd. Okay, let's move on to part C then. Given that points A, B and C lie on a straight line, find the value of P. So at this point, I'm going to want to draw a diagram to help me visualize and work out what I need to do in part C. So 10 across minus 3, minus 3, so that's 10 minus 3. I'm rewriting these position vectors as coordinates. Minus 8, so that'd be going minus 8 plus 9, so minus 8 plus 9, and this next one is going to be minus 2 up P, so it would be minus 2P. And I know to get from A to B, I need to go, what was it? It's back 18 and up 12. So to go from here to here, it was minus 18 up 12. So to work out P is going to be 6 on the x-axis in that direction and 12 in this direction. So if I break the problem down into working out its y component, I've gone 6 parts this way and 12 parts this way. So that means I've gone in the ratio 1/3 to 2/3. And the change in y is going down by 12. And if I divide that into thirds parts, that's 4 parts for each third. So I need to go down 4 from 9 to get me to 5. So that's a bit hand wavy, a bit not clear. Basically, let's try and explain again. The vector that I worked out previously told me to get from A, which is over here, to B, which is up here. I need to go up by 12. I've worked out using the ratio of the x components that I need to go 6 parts this way to get from minus 8 to minus 2, and then 12 parts to go from minus 2 to 10. That's looking at the x coordinates. So therefore I know that this ratio is going to be in a ratio 6 to 12, or in a ratio 1/3 to 2/3. So I've used that same ratio of fractions to move by the y coordinate, which was a total distance of 12 to get from A to B. So I've started at 9 and I've gone downwards by 4 to get to 5. So this coordinate here is now 5. And I could also have gone from minus 3 up by 8 to get to 5 as well, in a ratio of 1/3 to 2/3. So P is 5. State the ratio of the area AOC to the area of the triangle AOB. So AOB is going to be this triangle here, and AOC is going to be this triangle here. So so given how many marks we're getting for this C part 2 is only part of this 3 marks, and we've already used some of that in our calculation for P is 5, we're unlikely going to be working out the exact area. It's probably going to be some clever way of doing this with regards to ratios. So for AOB, which is the big triangle, I'm going to say that this is going to be a calculation of half times base times height. And the base I'm going to use as the line from A to B, and the height will be this little mini height from O to the line AB. Now, the only difference when I work out the area of triangle AOC is that C is going to be a lot closer. This is coordinate C here, and it's going to be only 2/3 of the value of the base. So it's going to be a half times 2/3 base times height. So our ratio is going to be a half base height to a half 2/3 base height. On our ratio, we can cancel out the bases and the heights, cancel out the halves. So it's 1 to 2/3, or in the ratio 3 to 2. So there we are. That is the ratio between the triangle AOB and AOC, 3 to 2. So there we are. That's the answer to question 13, worth a total of 7 marks. Let's now move on to question 14.